So, good afternoon, good evening, or good morning, wherever in the world you're joining us from. I'm Jarka Glassey. I'm the Executive Vice President of the European Federation of Chemical Engineering, EFCE, and I'm a biochemical engineer by training. I graduated from the Slovak Technical University in Bratislava, but I worked all my professional life in Newcastle University in the UK. And I'm really happy to be involved in the introduction to this webinar on innovative insect solutions, breeding, processing, and sustainability for future food and feed. And I'm really looking forward to hearing about this because this is actually one of the areas that we are working in with my group too. Let me just say a few words about the Spotlight Talk series. So this is now the 5th year of the Spotlight Talk initiative, which started in 2020 just to help us keep together the community during the COVID pandemic. But the success of the previous years convinced us to transform the Spotlight Talks into a regular feature of the EFCE program. So we now have one Spotlight Talk series in odd years and 2 in even years, like 2024. So in this autumn, 13 of our working parties and sections are delivering over 2 weeks short sessions of 3 or 4 talks focused on specific topics by leading industrial and academic experts. The series therefore enables attendees to sample matters in new areas and encourages cross-fertilization of interest. The complete program is available on EFCE website if you would like to join some of the other webinars. EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries, representing more than 100,000 chemical engineers in Europe. The working parties and the sections cover all major specific areas in chemical engineering and are in fact at the core of our organization, forming the scientific engine that drives many of our activities. They provide an important forum for technical exchange and networking among chemical engineers in Europe. I'm particularly happy that in this series of Spotlight Talks, we will have the first contribution of the newly re-established section of sustainability, with one separate Spotlight Talk already taking place this week and another one co-organized with the Working Party on Education going to take place next week. So before concluding, I would like to thank all the people who worked hard within the working parties, sections, and EFCE itself for this initiative to happen and to be successful. In particular, many thanks to EFCE's Martin Pou in Toulouse, who did most of the conceptual setting up and practical activities. So thank you again, Martin. And thank you for your attention, and I wish all the speakers and the attendees a fruitful and successful webinar. Now I'll hand back the word to the chair of the section and the vice chair of the section on food, Professor Henry Jäger and Professor Kemal Aganovic. Apologies, Kemal. I know you mentioned that you are a secretary and that the vice chair cannot be with us, but apologies again for that mishap. And let's start with the webinar.
Yeah, thank you very much for the introduction. Good afternoon from my side, and apologies that you can't see me. Obviously, there is some issue with my camera. Nevertheless, I would warmly welcome you on behalf of the section food and also on behalf of Volker Heinz, our chair or co-chair, and together with Kemal and myself, we are happy to drive all the issues, challenges, and opportunities concerning food and food engineering within the European Federation. And talking about our section, actually, one main focus is, of course, the exchange of knowledge, of innovations, finding solutions for the future challenges. But besides this knowledge transfer and networking idea, also the promotion of young scientists is one of our focus areas. And I'm mentioning this since we might have some young scientists in the audience today as well. And this is why I would also like to highlight another important event of our section besides the webinars, which is our yearly PhD workshop, where we are trying bring together the Europe's best PhD students in food science and technology. And this will happen again next year in April. And most likely your supervisors and your groups, your research groups active in the area of food science and technology will let you know and will motivate you in order to apply for participating at our workshop. Well, with those general information on the section, it's already time to give the word to Kemal, who was putting together today's program with a specific focus on the insects, which is clearly a challenge from a raw material side, but also from a processing side. But besides the challenges, of course, a big opportunity, as we will learn today. So with this, Kemal, the word is yours.
Thank you, Henry, and thank you, Jarka, for a nice introduction. Hello, everyone. Hello to the audience, wherever you are, and welcome to our webinar. We are very happy to see you all here today, and that we jointly explore an interesting topic that is actually gaining increasing importance and attention around the globe. And this is one of the reasons why we decided to go deeper in this topic. As you probably know, one of the main reasons is that the demand for food in general, not only for protein as well for a fat, is increasing with increasing global population, and insects are often described as an emerging and a promising solution, not only for feeding the people and feeding the planet, but also revolutionizing also animal feed and playing an important role in circularity and in general in agri-food sector. Today we have a very good composition of experts in different areas in animal breeding, in insect breeding, insect processing, as well then looking at a little bit the broader perspective on the sustainability and circularity. We had some last-minute changes in speakers if you compare the agenda to what is present in the screen, but I can convince you that the representatives are of a high quality, and they are for sure going to deliver a very interesting talks today. One last point, not to lose too much time, is I would like to highlight the forthcoming and the first Insect Plus International Congress. You see it in my background, which is focusing on alternative protein cultivation and processing. So in its name, it's insects, but the plus means that it goes beyond insect as a biomass. So the Congress aims to bring together global, so to say, alternative protein producers and suppliers, as well as investment community and processing technology providers, and of course scientists. And the topics, as I mentioned, include the whole value chain, as well as not only insect, but also plant protein, lab and unicellular proteins, as well as sea-based alternative, and in general biomass value cycle. So thank you for joining us today. I'm really excited, and I guess you are as well, to this relatively new field and everything that is coming to us today. And I'm looking forward and hoping to have really also fruitful discussions and engagement from your side. We will have around 50 minutes talk, and we will allow for 5 minutes questions and discussions just immediately after the presentation. With that having said, I would like to give word to Christos, who will present advancements in insect breeding with a little bit more primary production perspective, perhaps. So Christos, the screen is yours, so to say.
Before Christos starts, may I just quickly encourage everybody to use the Q&A tab to ask the questions? Is that okay, Kemal? And then you can read the questions out to the speakers.
Absolutely.
So,
thank you.
So rather than the chat, can you please use the Q&A?
Thank you for the remark.
Okay, perfect. Do you see the slides here or not?
Yes, but not in a presenter mode.
Oh,
Sadly.
man. Okay. Just give me 1 second to do it the traditional way to reopen the file. And this is due to the fact that we have a double screen here. Oh. All right. Okay. So, okay. All right, perfect. I think now it should work. Does it work?
Yeah.
All right, perfect. So, okay, without any further delay, let me minimize this one. Thank you for giving us the opportunity to be here and present some of the stuff that we do with insects. But it's far beyond insects, so we do a lot of different things that are combined with insects. So I'm going to be talking about some specific priorities that we have set in insect breeding and how those can interact with other things. One thing that I would like to start with is, you see the slides changing, right?
Yes, we see it.
All right, perfect. So one thing that we don't realize as humans is that 75% of our food comes from specific plant species. And when I say specific plant species, I mean 12 plant species and 5 animal species. And in those 12 plant species, we have the big 3, rice, corn, and wheat, which are very, very important for global food security. So this means that if something happens to one of those 17 species, this is an issue of global food security. So imagine the thousands of different species that can be utilized as food and feed at the same time in a multi-trophic level. This means that we have to move forward for new nutrient sources, and there are some nutrient sources that have been evaluated and have been registered in detail so far in different zones, like the algae, legumes, some specific plants that we tend to forget, but they have a very high protein content, different other sources like the cultured meat or the different fermentation sources, and insects, which is my topic that I'm going to be talking today. One of the key elements here is that everybody eats insects. Each and every one of us consumes about 0.5 kilograms of insects per year. How? Through feeding, through insect fragments, the so-called insect fragments. And this is why the FDA has set a specific. So I was discussing about the way that the FDA has set a specific limit of insect fragments for flour. There are some different kinds of limits that we call food defect action levels. So yes, there is a legislation background in the case of insects or insect fragments in food, in feed, and a different other agro food chain channels. In Europe, we are in zero tolerance. We are on the zero tolerance mode. So to my ears, this means that we don't count. This is why we don't have insect fragments into food. So one of the things that most of you people know is that in July 17, the European Union went ahead and gave the green light for the utilization of insects in aquaculture. And in those kind of insects, we have 2 major store product insects. So immediately we had a shift from store products like pests for food. So with this legislation, we changed pest status to something that is very, very valuable for mankind. August 2021, again, approval for insects in poultry and pig feeds. Pig feeds. Again, we had those 2 beetles inside in the catalog of the insects that are registered. And of course, in May 2021, we had the update of the EFCE annex, which was established back in 2015, when we had again different kinds of insects, including those 2 store product insects that were supposed to be pests and not associated directly with food. So this gave us the opportunity to proceed to the next level, which was to establish a rearing unit here in our university. Those are our facilities in the University of Thessaly, where we are different types of beetles and also black soldier flies. So I'm going to talk about some research priorities that we have established so far in our research. Number 1, the evaluation of agricultural byproducts. And when I say agricultural byproducts, I'm talking about materials of of plant-based origin, plant origin. So those are some of those are some materials that are already registered at the European Union level to be used for this purpose, for macerating protocols of insects. And this is how it goes. I mean, this is one of our first studies that we did 8 years ago, how those different byproducts go in comparison with others when we had the Tenebrio molitor rearing there, the Tenebrio molitor larvae. We saw two major things. Number one, that we had larger larvae, and number two, that those larger larvae were able to be produced in a very short period of time. So if you play with the right agricultural side stream, an agricultural byproduct, you can milk larvae. You have a lot of larvae in 50, 60 days. And if you mess with the wrong byproduct, you have to wait forever. You have to wait for 200, 250 days to get smaller larvae. So this means that from a practical point of view, it's a very important parameter for a company to consider. And this is the duration of development for the different larvae that were used here. The next thing that we did is that we tested different types of byproducts. So we were using wheat bran as a control, but we had different types of byproducts that gave very good results. And in terms of FCR, the feed conversion ratio, there are some byproducts that are much better than bran. And the most important is that those byproducts were much cheaper than bran. So this means that it's cheaper to use these byproducts and in a much more effective way. This is the number 2 research priority, the evaluation of genetic material. And to my ears, it seems that when we talk about insect breeding, we have in mind something like the chicken breeding. If we go to our grandmothers and grandfathers and tell them that now we have chicken that are more than 5, maybe 6 kilograms in weight, they will not believe us, because back then the best chicken was the one that was 0.8, 0.9 kilograms. So yes, if we breed chicken, you can have larger chicken or with high protein or with all the qualitative characteristics that you desire. So what we did is we repeated the same thing. We went to different countries, we collected different types of strains and different types of populations for the Tenebrio molitor. And yes, there were some major differences in the case of larval survival here. So you see that the German strain has a high survival. Some of the other strains have lower survival, but the most important is here. For some of the strains, you get larger larvae in a very short period of time, in 50, 60, 70 days. So you don't have to wait forever to get your big larvae and the big protein content. And this is also the adult survival. So if you have adults that you would like to oviposit and produce adults, new larvae and new adults, then you have to be able to select the one that has the highest survival rate. Again, the most fascinating part of this work was the oviposition rate. We saw that there were some strains that, like the Italian strain number 1 here, and the Italian and the Greek strain and the Spanish strain, that were able to produce close to 1,000 eggs per female. But there were some other strains that were not producing, were not able to produce that much of eggs. Like, for instance, the German strain was less than 200 eggs per female, from mate to female. And not only that, again, we had huge differences in terms of the way that the egg hatch and the larval emergence happened through time in the different types of strains. And this is very important from a practical point of view, because if you consider that about 80–85% of your eggs are produced within the first 40–45 days, then you can have a cut line, and then you can keep the eggs here, and you don't have to wait for the eggs in the next interval. You just replace your egg-laying females with new ones. So this has a huge practical importance from the practical point of view at the company level. Number 3, the effect of animal growth and development. A lot of studies there. Some of them are ours here in our laboratory. This is how we did it with sea bream and sea bass, and this is those are the different types of full fat or low fat insects that we produced for the sea bream diet, and the different types of substitution, like 5% substitution, 10% substitution in the types of the fish meal. And pretty much, I don't want to bombard you with numbers here, but clearly, whenever we had insects inside, we had a very good weight gain in the insects and a very good protein retention in the fish that were fed with Zoophobus morior insects. Very promising, very fascinating result. And even more fascinating is the chicken, and is the reaction of the chicken indicators whenever they are fed with an embryo molitor here. So we had the control, we have 5% in embryo molitor, 10% in embryo molitor, and this is how it goes. The weight gain was not much affected, but whenever we played with protein, then yes, if you feed with insects, your chicken with insects, you have 1.5% more protein, which is very, very important here. And number 4 and last, insects is much more than protein. So in the case of the other livestock and the other types of animals that we produce food, when you get the animal itself or some products of the animal, with insects, you get the whole of it, because if you put 1 kilogram of food inside, then you get 0.5 kilograms of insects and 0.5 kilograms of frass. And frass is registered as a fertilizer. So again, the European Union went ahead and gave the green light for the utilization of insect frass as a soil improvement agent. So this means that the vast majority of the companies now that are active in the production of insects are also active in the production and trading of insect frass as a fertilizer. And this is how it goes with the fertilizer. We started with spinach some years ago, and now we have done a lot of experiments for more than 20 different experimental protocols with more than 10 different plants. But those are the first results that we got from spinach, which were very impressive. And this is why we decided to go ahead with spinach. So the line over here in the middle part of the slide is the soil surface. And what happens above the line is the above ground development, and below the line is the below ground development. So you can see here the red bar here indicates the negative control, no fertilizer at all. The green one is the positive control, I mean, a commercially available fertilizer. The blue one is 0.25% frass only. The other one is 0.5, and the pink one is 1% only frass in the entire soil mass. And this is how you can see the development below and above ground. It's very impressive. More data are coming from the group here. So just want to summarize some of those things. I want to emphasize in 3 major issues here. Although in the European Union, we consider that everybody else is doing food waste, we do also food waste. And in fact, we are mega food wasters here. We are wasting a lot of food. So from the 1 billion tons per year of food waste, about 30% of that corresponds only in the European Union. And if we want to quantify that, this means that this corresponds to millions of hectares of grains with millions of hectares of a cultivated area, more than 1 billion liters of water. So this means, which corresponds practically to 1/10 of the Amazon, not the Amazon on the internet, but the Amazon, the real Amazon in the South America area. So this means that food waste is under debate for utilization as a food source for mass insect rearing in insect farming. The second thing that I would like to emphasize is now we are having a very growing market. We have more than 1 billion euros that have been invested, and next year this will hit 3 billion euros, and it is estimated that this will grow further by 30 times by 2030. But the most important is the last one. Within the pandemic, the EU annual meat production has been decreased from 55 to 49 kilograms per person within the EU. At the same time, in Asia, there was an increase from 30 to 35 kilograms per person. So compare the 350 million of Europeans with the 3.5 or maybe more billion of Asians, and consider what's going to happen in the very near future in terms of need for animal-based feed. So that's it. Sorry for those interruptions in the connectivity and the connectivity issues. I would like to thank the group here, and I'm ready to receive your questions. Thank you.
Thank you, Christos, for a very nice overview. I think we have time for some questions. The first question was related to the composition of amino acids of insect proteins, and in general on the protein content. I guess there is a lot of data on that.
Yes, there are plenty of data for the amino acid composition. It seems that for specific types of amino acids, insects need support whenever you want to boost the mass insect protocols further. And now our attention has gone to other items like minerals and vitamins, which seem to play a very pivotal role, just like in the case of other farmed animals. So I think that, and the way that I see the new publications that are coming, all the more people are focused more on those two items, minerals and vitamins. So those will play a very critical role in insect nutrition protocols in the very near future.
I would also like to add, I mean, we focus a lot on insect proteins, but we shouldn't underestimate the insect fats, no? as a very useful ingredient which can be obtained. Did you look into fat content and the fat composition of insects, and then in a different substrate and so on?
Yes, the fat part is like okay. I think people that work with feeding trials realize that gradually fat is more than a bad thing in comparison with a good thing. And the results that you are getting, and it's very, very vigorously expressed in the case of chicken, turkeys, and also in the case of some specific fish like salmon and tilapias and freshwater fish. So this means that perhaps defatted food, insect-based food, may play a more important role in the near future. In the beginning, we were making the same mistake again and again by feeding the fish without defatting the different agents there. So now we learned our lesson, and we're trying to figure out how to reduce the fat in the raw materials that we provide.
Okay. Another question, great presentation, it says, and the question is around how economic is the insect production compared, for example, to plant-based production. In my opinion, it's okay. On one side is the economy, and then again, the size of the production plays a significant role in order to reduce the cost. But on the other hand, as I said in an introduction, that the insects are very good tool to close the loop, basically in the circularity. That's another advantage that is often somehow neglected.
Yeah, and I would like to add on that is that I consider that it is rather unfair to compare insects directly with other protein sources like soya, because soya has a lot of protein, but insects are not only protein. They have many other things like vitamins, omega-3, omega-6, antioxidants, many other things. So the comparison should not be direct, and we have to see the whole thing as a food source rather than compare the protein of one substance in comparison with the other. And as an agronomist, I keep saying to my students that we as humans spend thousands of years trying to prevent to save grains that have 11% of protein from insects that have 45% of protein. So we were killing the high protein source in order to preserve some low protein sources. So now we have to consider an alternative way. Maybe grains should be fed on insects eventually.
Yeah. Well, great discussion, and there is, I'm not sure if you see, but there are lots of questions, and due to the time, unfortunately, we cannot answer them all in the real time, but you can access the Q&A area, and then we can try to answer it there in a written form.
Perfect. Thank you.
Good. Our next speaker is coming from the industry, from company Alfa Laval, with a company that has a long tradition and expertise in separation technologies of all kinds. You might know them for some centrifuge or separators, as well as heat exchangers and so on and so on. Andriy Revva from Alfa Laval, he will tell us a little bit about innovative separation technologies of the insect biomass. Andriy, please.
All right. Hello, everyone. I'm going to share my screen. Please let me know if everything is visible.
Yeah, we see the slides.
Okay, excellent. Yeah. So as mentioned, I would like to introduce you some, let's say, some processes and some solutions for separation and industrial processing of insects. And I would like to start by basically looking at what are the traditional methods of processing insects. And when I say processing, in let's say from our side, it's more the way of transforming the biomass and separating the valuable fraction from each other. And let's say there are two groups of how the insects can be processed. One is the more classical, which we call a dry rendering, and the one that is, let's say, more specialized is the wet rendering. I would like to first start with the dry rendering. This is a very commonly used method. It's fairly simple, and it basically, let's say, is used normally for removal of the water from the product, from the biomass, followed by the separation of the solids. In this case, it's an insect meal, and the separation of the lipid fraction. This is a very straightforward process, and essentially the main elements of this process is the thermal separation of the water phase from the insect raw material. Essentially, the biomass is heated in some sort of a cooker or a dryer, and the water is evaporated. What is left after this process is a slurry, which is essentially the solids, which are the proteins and the chitin and other elements, and the lipids. And typically, this slurry is further separated in a so-called press filter, or let's say in the press, where the solids are squeezed together and the lipid fraction is separated from the solids. And then solids afterwards undergo the drying, and this is your insect meal. And then the lipid fraction can be further processed in different ways, either by centrifugal separation or filters. This is a very straightforward method, but it has some disadvantages that are quite important to understand. And one of the biggest disadvantages is that this method is an extremely energy-consuming method. It uses over 1.2 tons for every ton of water evaporated. And it's also, let's say, delivering a relatively low quality end product. To illustrate that a little bit, on the next slide, you can see the comparison of the oil or the lipid fraction derived on the left-hand side by the dry rendering method, followed by the press for separating the lipids. And on the right-hand side, same raw material, but the lipid fraction coming from the so-called wet rendering, which I will discuss in more details in a few moments. So you can clearly see the difference in color. What you cannot see, but there is a big difference in the levels of oxidation of the lipid fraction, which is extremely high or much higher coming out from the, let's say, more traditional dry rendering processing. So when it comes then to what are the alternative ways to process and separate the material in a better and more efficient way? Well, what we can offer as an alternative is the so-called wet rendering method. And what is the difference? I mean, what is so different about this method compared to the more traditional ways? The main difference lies in the separation of the different fractions from larvae or from the worms, for the sake upfront the drying. So we use, and I'll show you a few examples, but what we use is that we separate three fractions, being the lipid fraction, the water fraction, and the solid fraction, prior to doing the final drying to achieve the insect meal. The way we normally do this is that first we take the insects and we convert them to puree. This is typically done to improve the pumpability of the material, but also to improve the efficiency of heating and consequently efficiency of the separation. After the puree is done, we need to heat the raw material in order to coagulate the proteins, in order to release the moisture that is naturally present in the raw material, in order also to release the lipids and make them possible for separate. The heating can be done in several ways. This is just a few examples of what is often done in the industry. The heating of the insect puree can be done by direct steam injection, where the raw material is being basically pumped through in this case, it's a direct steam injection heater. The pump is pumping, the product is agitated through the flights, and the steam is injected. Normally, we warm up the product to approximately 95 degrees Celsius, and this is an excellent temperature for efficient separation afterwards. There's also a way to warm up and heat up the product without injecting the steam, and there's different methods. It can be tubular heat exchangers. We prefer using scraped surface heat exchangers as in this instance, but essentially the main purpose is to coagulate the proteins, release the stick water, and release the lipid fractions. Once that happens, the puree that is heated is introduced into a three-phase decanter centrifuge. And here we use centrifugal force to separate this mass into three fractions. As you can see on this picture, one fraction is the solids fraction. It's still wet, but let's say it contains all the solids. The other fraction is the stick water, which typically contains approximately, I would say, around between 2 to 4% protein, and then there's a lipid fraction. And all of the fractions are valuable and should be recovered. So if we follow then each fraction individually, and here actually on this video, you can see a process of separating of the product within a decanter centrifuge. Essentially, it's a horizontal centrifuge where the raw material is subjected to centrifugal force, and in this way, we're able to separate the solids and the liquids into three phases, and then the solids are removed by the actively moving conveyor on one side of the machine, and then the liquids are separated and removed on the other side of the machine. So essentially, by putting the raw material, like you've seen in the previous picture and also here, you end up getting three fractions out, one being the solids, the other one being and the last one being the lipid fraction. And here you can see how each individual fractions, what they look like. And that there's very little amount of water and suspended solids in the lipid fraction, and the same applies to the stick water. I mean, these are just some examples of what we normally see, let's say, in the industry, and in the light liquid phase, which is the lipids, we typically see after the first separation step around 2% solids, and we see about the same for the stick water. And the solids would typically contain 40 to 50% dry matter on the dry matter basis, and the rest is moisture. And there's typically around 17% fat in this. Then, if we then first follow the lipids fraction, what happens with it is that it's normally processed on a centrifugal separator. For some of you might know this machine. That's what's also used in the dairy industry to make skim milk and remove the cream from the milk. Essentially, what we do is with the lipids fraction in this machine is that we introduce it again in a stack of the rotating discs. The centrifugal force is applied, and it pushes all the small suspended solids to the outside of the bowl. It cleans up the liquid, and then there is a liquid to fat separation as well inside. And it gives us the possibility to separate a very, very clean lipid fraction, a very, very clean stick water fraction, and then discharge the solids as sludge. If we now follow the second liquid product coming out from the first separation step, the stick water. The stick water contains a lot of protein, and it makes absolute sense to recover it and use it as part of the insect meal. However, there are different ways how to concentrate it, how to get rid of the water that you don't want to have it. And the way we normally do it is that we use plate evaporation systems, where we basically boil off the water and the vacuum using the rising film plate heat exchangers. Depending on the capacity, depending on the duty, I mean, there's so many different configurations. You can remove the water by using live steam from the boiler. In a multiple stage evaporation system, we can also use electrical power to initiate the boiling and remove the water in the same way. And in some cases, we can use the waste heat coming out from the insect meal dryers as well. It does require a specific type of the dryer, but let's say that is also a possibility. And let's say, why do we at all want to recover this stick water? Well, essentially, it's because it contains a lot of proteins, and it contains actually as much proteins as which is equivalent to roughly 6 to 10% of the total available proteins that can be recovered in the insect meal. So it makes excellent opportunity to increase the overall yield of production, and an evaporation system provides the possibility to do it in a very energy efficient way. So by applying this combination of, let's say, centrifugal separation, first for the raw material and then for the lipids, and then also thermal separation by using the evaporation system, we are able to reduce the overall energy consumption quite significantly, often by 40+% compared to the more traditional dry rendering methods. And we are able to achieve dry insect meal typically containing around 12 to 15% lipids in the dry matter. And I'd like to just for the sake of accuracy mention that these values are mainly applicable for the black soldier fly, and they might be slightly different for other insect species. Some customers and some industry players that we work with would often also have the requirement to further reduce the fat content or the lipids content in the insect meal. That is driven by many factors. First, I mean, some of the factors are the requirements of the end users who buy the insect meal and use it, for example, for pet food or as a fish meal replacement. But also it gives the possibility to further increase the fraction of the lipids. That is also a product in itself. So we also looked from our side, what can we do? What kind of separation techniques we can apply to further remove the additional amount of lipids from the product. And this can be done by using a so-called double decanting or a double separation method. What lies in this method, essentially, is very similar in a way to what I have just explained, but we use the decanter twice in a little bit special way. So essentially, we try to remove as much lipids as possible in the first decanter centrifuge, but we also try to recover additional quantities of the lipids in the second step. The way we do it, I mean, the upstream of the process is very similar, but then the first separation step is done in a very special decanter where we got the inspiration from the olive oil industry for recovery of the oil. So this machine has been modified and improved also to be, let's say, efficient when working with insects. And essentially, the first separation step is no longer focusing on separating the solids and separating, the water and then the lipids. In this instance, we are then only focusing on separating the lipid fraction from the rest. And this process allows, using the special machine, this process allows getting an extremely clean lipid fraction and remove basically all available lipids that are in the liquid form from the raw material. What comes out from this separation step in the decanter centrifuge essentially is the lipid fraction, which goes directly to the high-speed separator for final purification, and it's a slurry that is a combination of the solids and the stick water. What happens with the slurry is that while it's still inside of the decanter centrifuge, it actually is still separated inside into two fractions, the solids and the liquid. Once this slurry is discharged from the machine and it's no longer experiencing high G-force, the stick water and the solids are recombined once again, and the stick water absorbs a certain amount of the water back into its structure. And right after this has happened and we have mixed everything properly, we introduce this mixture to the three-phased decanter centrifuge once again. and we repeat the let's say the separation inside, and in the similar way as I just explained before, where we subject this slurry to a high centrifugal force, and we split it once again into 3 fractions. We recover a small quantity of lipids, but enough to reduce the final content of the fat in the dry matter for the insect meal to be below 10%. How much below depends, of course, very much on which insects are being processed and on the actual composition of specific insects based on what sort of feed they were getting. But otherwise, the process is very similar. The main advantage of using 2-stage separation technique is that it is possible to achieve the insect meal with the very low fat content, plus additionally recover a certain additional quantity of the lipids or of the fat. It does, of course, require slightly higher investment. It does require a little bit more space on the production floor for the additional equipment, but also the benefits are many since the product becomes highly defatted. And it's becoming also more attractive, let's say, for the off-takers who will be using this insect meal for their purposes. So to summarize a little bit again, let's say traditional methods versus separation in the decanter centrifuges and high-speed separators and evaporation system. What are the advantages? A more traditional way of processing the insects is clearly a very simple and straightforward technology. Equipment is easily accessible. It's accessible on the market. Second-hand equipment as well is available. So it's fairly easy, let's say, way to start insect processing on the industrial scale. However, the downsides will always be that from day one, you will be getting lower quality end product. The lipid fraction will be highly oxidized. There will be an extremely high energy consumption. And it's it takes a lot of time to start up the system and stop the system, and the process can never be done hygienic. And currently, at least in the European Union, it's not possible to process the insects into human food. However, this requirement can be changed in the future. So it's also important to understand that with the traditional methods, you are kind of stuck to always operating in the animal feed or fish feed space. With the wet separation technology and with using the decanters and centrifugal separators evaporation system, it's possible to achieve a higher quality products. And this goes hand in hand also with the speed of processing, where the speed of processing with the wet rendering is times and times higher compared to more traditional methods. Energy consumption is significantly lower, typically anywhere starting from 40% lower and up. The equipment can be done more hygienic, which is a requirement for many pet food manufacturers who require their sub-suppliers as well to manufacture their ingredients in a hygienic way. The systems are quicker to start up. They are much more flexible. However, there are some downsides like addition of moisture in the process and also higher maintenance costs. But let's say our take on this is that the wet rendering method using centrifugal separation has a lot of advantages, both in terms of generating high quality end products, recovering more fat, but also, let's say, making a more future-proof processing lines that can be in the future approved as food-grade processing lines. That also gives certain additional possibilities for the companies processing insects, since a better quality product with lower fat content, with higher digestibility, will also be a more attractive product on the market and makes their business case more successful. That was it from my side, and I will be happy to answer any of your questions.
Thank you, Andriy, for a very, very nice talk. We have few questions in the Q&A session. Regarding the temperature in the slurry, but I'm not sure to what exactly that refers. Let's maybe move to our next question. What capacities for insect processing is Alfa Laval offering at the moment? At which scale?
I mean, essentially, the equipment we have and the processing method that we work with can process on the industrial scale anything from, I don't know, a few 100 kilograms an hour on the low end and up to, I would say, at least 20 tons, 25 tons on the high end, high end of the scale, production scale. But most typically, at least currently, the size of the plant that we see here and there, the production capacities are anywhere in the, a couple of tons an hour and up to maybe 6, 7, 8 tons an hour. And that is a very comfortable capacity for the equipment.
When you mentioned the two-phase separation, two-phase separator, is that two phases and then or two separators after, or is it two-phase one separate and there is additional one? There is a little bit of confusion in the audience.
So basically, just maybe repeat a little bit. There is two ways of processing. One way is only to use one horizontal centrifuge, which is, we call it a decanter, only one decanter. In such case, this decanter separates the product into three fractions, being the lipids, the solids, and the stick water. However, if the target is to achieve higher levels of defatting of the raw material and getting a lower fat content in the final insect meal, then we use two centrifuges. One centrifuge is a two-phase, which generates the lipids or the fat fraction and the solids and liquid combined. And then the second centrifuge is a three-phase separation machine, which separates it into oil fraction or fat fraction, lipids fraction, into the stick water fraction, and then into the solids.
All right. Now we have redefined the temperature question, was related to the temperature of the slurry at the decanter.
Yeah. We normally prefer running with temperatures around 90 to 95 degrees Celsius. That has to do with several factors. One factor is at these temperatures we're able to achieve very nice pasteurization effect on the slurry, basically removing or killing the unwanted microorganisms in the slurry. At the same time, also the separation efficiency, when you separate the solids from the liquid and the liquid from the fat, it gets also improved. The efficiency of that separation is higher at an elevated temperatures. So what we have seen at this temperature, we both achieve a very efficient separation, plus we also achieve the pasteurization effect.
And probably some enzyme inactivation, oxidative enzymes in parallel as well.
That are naturally in the insect, in the stomachs and so forth, yeah.
When you talk about these processing systems, they, I guess, then suitable for all types of insect, or there's a little bit of fine-tuning in the end?
I mean, the equipment essentially is exactly the same. The only fine-tuning is the actual setup of the equipment, mainly understood in a way that if you have insects, for example, with higher fat content, you might need to adjust the equipment to process larger quantities of fat versus the insects that are lean and have very little fat. I mean, but the machines are exactly the same. What we have so far been processing, let's say on the industrial scale, is black soldier fly, mealworm, and crickets. That's at least the three different species that we see, let's say, are mass produced. But essentially, you could process pretty much anything you like. As long as it's pumpable, you can process it.
If it is transferable from milk to insects, then it's much easier from insects to insects, I guess.
Yeah. There are, of course, nuances because, some species might be more difficult to process than the others because of the nature of the of the insect, but it's possible most of the time.
All right, we have two more questions so far, I see, and I guess we can answer it before the break till 3 o'clock.
Sure.
You mentioned a low energy two-stage wet process, and on the other hand, you said, okay, the footprint is larger. So how you justify that? It's a little bit contradictory. One of the
when I say the energy, I specifically refer to the energy that is used for water removal from the product, because that's the biggest source of energy that is applied in the insect transformation. You need to apply energy to get rid of the water that you don't want to have in your product when you dry it. So from that point of view, the energy consumption for water removal will be exactly the same for a system with two decanters or the system with a single decanter. When you introduce a second decanter, energy-wise, you're only adding the electrical power consumption for the machine, which is not huge. Of course, depends on capacity, but relatively it's not huge. But the energy used for water removal and eventual drying of it will be exactly the same. There will be no difference.
Yeah. All right. The last question relates to the utilization of oil as a separated fraction. And as I mentioned in the beginning, yeah, if we think about reducing the number of animals, for example, or introducing more insects, in the end, it has to go the same route. That means that on one hand, we have a protein, and on the other hand, we have a fat fraction, and both should be utilized in an optimal way, and preferably both of them for food. Of course, there are some other application in a pharmacy or in a cosmetics, in a biofuel production. Pharmacy or probably cosmetics would be of a higher value. Biofuel. Do you have any experiences with the utilization of oils, fats?
I'd say we have a little bit indirect experience with this, since it's let's say the customers we work with, they are the ones that are utilizing. But what we hear that it's very often used as one of the ingredients for pet food or animal feed. For example, what I've heard, let's say one of the recent applications is that the lipid fraction is widely accepted as an ingredient for piglet feed because it contains, if I recall correctly, oleic acid, which is highly, let's say, desirable for piglet feed. It reduces the mortality rate, it boosts the immune system, and so forth. It's also used in for example, in various pet food applications, like for food for cats and dogs. Since both the insect meal and also the oil, I mean, they are hypoallergenic, so they are helping, let's say, animals consume the food without having any allergy issues or rejection the food. So that's also the application, at least that I'm aware of. But there can be multiple. I mean, it can be used as any other animal fat in principle. I mean, both for cosmetics, also for energy purposes, for fuel purposes, if that is where there is a requirement, but otherwise as any other animal fat for animal feed applications.
Or even plant. I mean, it just has to go through the certain refining process to get really any unpleasant odors and so on. Yeah. And we had a master thesis running at the institute, was looking in a food application, and the student made some cookies, for example, and some nougat mass was actually quite good when you have a refined fat or refined oil.
That's absolutely possible. I think the only obstacle at the moment is the legislation that prevents it being used. And once that obstacle is overcome, I mean, that will open up a lot of doors for using the different fractions in food industry.
Good. I mean, there are some safety issues, but we've seen also in the first presentation, and the questions were a lot about allergenic potential and allergenicity, safety, mostly again related to the substrate that is being used. As long as we use a let's say feed grade substrate, the risks are relatively low, but there is a lot of work on the scientific part as well to be done.
Yeah.
All right, Andriy, thank you very much for the talk. And for the first two speakers, according to agenda, we have a short break now, just 5 minutes to maybe stand up a little bit, grab a coffee. If there are any questions remain unanswered, please retype it in the chat, and then the speakers will take care of that and answer in the chat directly. I'm sorry that we could not consider all of the questions. It's great that there are so many, but due to the time, we have to keep it at least to some extent on time. And with that, I would like to introduce the break and give the word to Henry to continue with the second session.
Looking forward, and see you then at in 5 minutes, 3:07 for the Central European time.
Sounds wonderful.
See you in 5 minutes.
See you then.
So, I hope that everyone had a chance to enjoy the short break, and probably time to restart into the second part of today's webinar on insects for food and feed applications. And the third presentation is waiting, and it fits quite nicely to what we have heard so far. We've learned about the raw material. We had a deeper look into processing, and now, of course, it also comes towards application and then benefits of insects, insect-derived ingredients in food and feed. And this will be at least one part of the presentation we will hear now from our colleagues from the Leibniz Institute for Agricultural Engineering. And as Kemal mentioned in the program, Oliver Schlüter, our friend and colleague, was mentioned, but Giacomo Rossi, a team member of Oliver, stepped in. So thank you very much for giving us some insights into the insects applications and benefits. Big research focus area at ATB, as I know. So we are looking forward to learn about the recent activities. Thank you.
So, can you see my screen?
Yeah.
Okay. So thank you very much for the kind introduction. So I'm Giacomo Rossi. I'm a PhD, still a PhD candidate at the Leibniz Institute for Agricultural Engineering and Bioeconomy in Germany. And yeah, I'm here on behalf of Oliver Schlüter, my supervisor, that unfortunately couldn't join the meeting. So first of all, let's say that in ATB, the research that we do on edible insects, it's a research at 360 degrees because we are investigating different aspects, starting with the production, so rearing insects on different substrate. And then we go on, of course, processing and transforming the insects in some, let's say, some nice product then can be used for, can be integrated in traditional food product or food feed, or can be used for other application. And of course, one interesting aspect that we will focus on, but I will not mention on this presentation, is also the environmental impact of the edible insects. For example, we studied a lot the gas emission from insects. We were able to develop a system for measuring on lab scale, so on small scale, the greenhouse gas emission of insects in a continuous way. So, but as I mentioned, I will not say anything about this because then the following speaker will touch the sustainability aspect. So in this slide, you can see that more or less I will touch a different aspect, mainly focusing on food safety and the legislation. I've seen that there are quite a lot of questions about, quite a lot of interest about this topic. And then, of course, I want also to mention something that go beyond the quality, and then I will speak a little bit about the benefit of consuming insects and how the insects can really play an important role as changers in the world, in the future world. For starting, I would like to mention this that was said by Jeffrey Tomberlin, that is not just about food and feed, but it's about creating an environment that allows us to feed the world. Actually, I agree with this, but up to one point, and you will see that it's much more than just create a new environment for feeding the world. So when I prepared the presentation, I was like, I started from a very broad topic. I start with a little bit understanding what is the condition of the current food system. So we know that the world population is increasing. We know that the level of income is increasing, so the wellness of the people is increasing, and then we know that we need more food. Actually, right now we produce around 4 million of metric tons of food every year, and this amount of food it's enough for feeding all the people in the world, for feeding much more of the people that are present now in the world. But the problem is that the resources are distributed in not evenly way. So it means that there are some people, like around 38%, 40%, that are suffering overweight and obesity, and other people, like around 10%, that are experiencing hunger every day. So then we need to do something for compensate this thing. So and then one idea would be to distribute better the resources. Another idea would be to change the diet toward, for example, plant-based product. And but these solutions are seem to be not enough. So we need to change really completely the food system from the production to the consumption. For example, in these two articles that are very recent, one is from 2018, one is from 2022, was mentioned that if we are able to incorporate a novel food in the European diet, we can reduce the environmental impact of the food system up to 80%. And then in the other study was also mentioned that by combining the different novel food, we are able to satisfy, let's say, to encounter all the nutritional requirements of the people. So then, jumping inside the topic, the insect topic, we see that nowadays the concept is to use the food waste for rearing insects, and then using insects for rearing animals, so for feeding animal, or directly for food. This concept, so I just create this term, the fly economy, that is a circular economy based on insects. But the problem is that the European legislation doesn't allow this to apply this fly economy, because we know that there are a lot of food waste that are wasted every year, but the European legislation consider insects as farmed animal. It means that we can rear insects only on feed that is allowed for other animals, but not on waste. This is true up to one point, because actually some waste are allowed. The ones that are not allowed, so cannot be used, are all the waste that contain animal product, so animal meat, animal carcasses, fish, but also restaurant waste, catering waste, and of course we cannot use manure. So this happens, so this legislation is mainly because of food safety reason. And this apply regardless by the final destination, the final use of the insects. So if we want to rear insects for food feed, we cannot use waste. If we want to rear insects for pest management, for example, we cannot use waste as well, because insects are considered farmed animal. So going more on the detail in food and feed application, we have already seen that from the first presentation that the European legislation is, let's say, is changing almost on daily basis. And right now, 4 different species of insects are allowed for food, and 8 different species are allowed for feed. In terms of food, first of all, we know that insects are considered novel food. So it means that we apply the novel food legislation. So it means that for including one novel food, one insect on the food supply chain, we need to get the permission, the authorization from the European Union. The problem is that right now, of these 4 species already authorized, they are authorized only indeterminate in a certain form. So, for example, Tenebrio molito, that is the mealworm, only all dried or all frozen. Locusta migratoria, that is the grasshopper, also powder. Acata domestica, cricket is possible also partially defatted powder, and so on. The problem of this legislation is that, something positive is that when one novel food is authorized in Europe, everyone can produce that novel food. But on the other end, that novel food should have the same, should be processed and produced in the conditions that are authorized, that are included in the dossier authorized by the European Union. And this dossier is secreted for 5 years. So it means that nobody except the European Commission and the applicants know the form and the real condition for producing this novel food. And this, of course, it's a problem because another company that want to enter the market with the same novel food cannot do this unless doesn't produce the food, so the insect doesn't produce and process the insect in the same condition as specified on the dossier. In terms of feed, the legislation is a little bit more allow a little bit more things. In general, different species are allowed for pig, poultry, and fish, but not for ruminants. For ruminants, the only thing that can be used is insect fat and hydrolyzed insect protein. This because the main problem with ruminants is the mad cow disease that is caused by prions, and after the hydrolysis, for example, it's assumed that these prions is not dangerous anymore, so the protein are not dangerous anymore. So, like I say, all of this problem connected with the legislation for food feed, but also, for instance, as waste management tool, is connected to the food safety. So we know that in insects there are several food safety hazards that can be classified in biological hazard, chemical hazard, allergens, mainly. This hazard came from the rearing, so from the substrate, but they can come also from the processing. For example, from the substrate, this is so we did a study where we used black soldier fly for grow on aquaculture waste that actually is manure from fish production. We have seen that the microbial load of the substrate and of the insects is always high. This is, of course, because of the gut, because insects usually are processed with the gut, and the gut of any animals contain a lot of microorganisms. So the fact is that we didn't measure, we measured, but we didn't detect any salmonella and listeria that were pathogen that are pathogen for human and for animal. Actually, this is not completely true because we detect salmonella on the substrate, but not on the substrate containing waste, so any fish manure, but on the substrate, the standard substrate that contained chicken feed. So actually, it's like to say that this substrate that is allowed is more dangerous in a way that the substrate that is not allowed by the legislation. So this means that the legislation is not always, doesn't make a lot of sense always. Concerning the mycotoxin and the heavy metal, the level of mycotoxin and heavy metal on insects always depends on the substrate, but this depends also on the insect species because some species accumulate heavy metal and mycotoxin, other species no, but different mycotoxin behave in different way on the insects, and it's important also to consider the initial concentration on the substrate and the rearing condition, because we have seen that if we rear the insects for some days, like 24, 48 hours on the non-contaminated substrate, the insects that contain mycotoxin actually are not are free from mycotoxin or from heavy metal. Interesting is also allergens. I didn't touch on the presentation, I didn't put anything on the allergens. I know that there is quite a lot of interest from the audience. I can mention that the allergens are the same as shrimp, and usually the people that are allergen to shrimp should not eat insects. But it's also true that there are some studies where they show that people that got sensibilized to an allergen from insects, they are not sensitized. They are not allergen to shrimp. Then, of course, how to increase the safety of insects is the main way is the processing. For example, we did several studies, and in one study published in 2020, we have seen that every processing step has an direct effect on the microbial load. And in general, they lead to a microbial count reduction. Of course, different type of processing can result in different product. And every processing has also a strong impact on the physiochemical quality of the final product. For example, we have seen that high pressure, hydrostatic pressure, that is a novel technology, but it's quite interesting and attractive, and also used nowadays on the food sector. Is able to reduce the microbial contamination, but on the other end, it can also trigger the lipid oxidation, because we have seen that there is an increasing amount of malonylaldehyde on the insect paste treated at 600 megapascal for 5 minutes. However, we have done several experiments, several trials, and in some trials we have seen this increasing. We are talking about Tenebrio motor, sorry, I didn't mention before. In other trial, we didn't see anything. So then we did a further study by comparing different treatment conditions, so 200, 400, 600 megapascal for different time. And then we have seen that the lipid oxidation is present at lower pressure level. It is quite interesting, because the most effective treatment in terms of microbial reduction and enzymatic inactivation are the treatment at higher pressure level. So it means that if we treat insects at high pressure level, and regardless by the time, we can get something very interesting. Of course, in this case, we need to consider the price, of course, the cost. But it also means this behavior of the insects is quite interesting, and put the insects in a very close condition as the fish. But it's completely different in meat. So it means that every material, so every processing, should be tailored to the specific material to be treated. And of course, after this, we need also to consider the sensual quality of the insects, because, as I mentioned, every processing has an impact on the physiochemical quality, and it will impact indirectly also the sensorial quality. So, for example, the flavor, but also the technofunctional properties and the antioxidant quality, and so on. Of course, beside the processing, we need also to obtain a product that can be safe after several times, and that can be consumed safely after several times. So we need to focus a lot on packaging and storage. For example, we have seen that in several experiments, we can reduce the lipid oxidation by using MAP, modified atmospheric packaging, without oxygen, but at the same time, these conditions are not always the best for keeping low microbial growth. Of course, everything depends. So the choice of the packaging and the storage system depends a lot by the product, because if we have fresh insects, so high water content, and then high water activity, the main problem can be the microbial contamination. if we have dry insects, low water activity, the main problem can be oxidation, while the microbial contaminations with low water activity is usually it's not a big problem. Then, of course, up to now, I spoke about the all insects, but we can, through processing, we can also make some interesting derived product, for example, flour, for example, paste, but we can get some fraction, for example, lipids on, so insect oil, insect protein, defatted insect meal, and so on. And we can include this product on some already prepared food, some food formulation or feed formulation. For example, we can do extrusion, we can do we can pelletize the insects and make pellet. We can make pasta out of insect flour. Of course, the pasta will not contain only insect powder, but will be like a blend of wet flour and insect powder in concentration that usually are not higher than 15%. We can make cookies and so on. So for concluding, I would like also to mention that insects are not only, doesn't contain only nutrients, so are not only good for the environment, are not only good for in terms of nutrition, but are good also for the health of the people. Because insects contain chitin, contain lipids and protein, bioactive peptides that can be considered altogether bioactive compounds that can help us to prevent, for example, coronary disease. They can play anti-inflammatory, anti-tumor, antimicrobial, antioxidant activity, and so on. So, and at the end, I want also to mention that up to now, we always spoke about insects as food and feed, but insects are much more, because insects can be used for in agriculture, for example, for pest management, for pollinators. Insect frass can be used as fertilizer. Insect can be used for food and feed, of course, but insect can also be used in medical biotechnology, for example, for producing drugs, antimicrobial peptides, but pharmaceutical products, but they can be used also in industrial biotechnology for producing biofuel, enzymes, biolubrificant, edible coating, cosmetics, of course. So at the end, I want to reconnect to the beginning by saying that it's not just about food and feed, and it's also not just about creating a new environment that allow us to feed the world, but it's about creating a new life concept based on the valorization of insect and insect-derived product. So, and with this, I would like to conclude my presentation by renewing you the invitation to join our international congress, first international congress on insect and other alternative biomass that is called the Insect Plus, that will take place in Quakenbrück in Germany between the 12th and the 14th of May 2025. Thank you.
Thank you very much for the interesting overview on the attributes related to food and feed applications, and also thank you for pointing out the numerous opportunities besides well, the protein and the fat that we have discussed so far. Though the biotechnology, what you mentioned just at the end, is certainly a very important point as well. There is a question on the amounts of insects. I think at the beginning of the presentation you mentioned a figure about 4 million tons per year, and one of the participants is just asking if this isn't too low considering the total amounts, and is posing also an interesting question. What is actually considered? Is it the registered production, or how is the insect business currently, and where are the figures are coming from?
So, okay. First of all, I should mention that it's not 4 million, it's 4 billion. I just wrote, so it was just a type error. And then, so you mean the figure are coming from, sorry.
Yeah, no. I mean, with this clarifies. However, still,
Okay.
the second part of the question was if there might be a difference between registered production. So, how far is the industrialized level? What role do the big players play? Maybe also compared to regional production concepts that might
So
even be out of any statistics.
for sure, there is so the industrial production is considered. The small production sometimes can also not be completely considered. So that are estimation from FAO. So I assume that are quite comprehensive, but of course it's so we cannot be sure that it's
Yeah.
real.
I see. Okay.
Yeah.
Good. Thank you. I don't see any further questions coming here. So if there are still, you have the chance to type it in the question and answer, and the speakers will have an eye on this and are happy also to provide the answers then in written form.
Yeah.
So thank you again, Giacomo. And the next speaker is ready. I see Dusan Ristic from DIL, and he is also linked to our BOKU University as a PhD student. So I'm happy to see him here. Again, on behalf of the speaker Sergei Smetana, who was initially planned to give this talk. And now it was mentioned several times, sustainability, and of course also the quantification of sustainability is an important point in order to quantify one big benefit that is always linked to insects and insect-derived food and feed materials. And I guess Dusan will now get some light into this topic and address the sustainability issues in particular in his talk. Thank you, Dusan.
Indeed. Thank you very much for the introduction. As I said, my name is Dusan Ristic. I'm a PhD student at BOKU and also research associate at DIL. And I will present instead of Sergei Smetana, who couldn't join us today. I hope you can see my screen already. DIL, you can, okay. So DIL that both Sergei and I are coming from is now already over 40 years old, and is based in, as Sergei would love to say, best place in the world called Quakenbrück. And we're a German Institute of Food Technologies, but also we're much more than that. We're a part and we're the main part of Technology Campus Artland. As you can see here, there is a number of DIL associated members of the campus. There is a technology center that was organized and made with our partners from Bueller. There is also the Business and Innovation Park Quakenbrück. And even beyond that, we like to say that in Quakenbrück we have our factory village, which involves also some industrial partners beyond those that are within the campus right next to DIL. But then here you can see the cattle production, which seemingly has nothing to do with insects. And normally when we say cattle, in terms of sustainability, it is perceived as the main villain of food sector, with good reasons. Many would say maybe that cattle can also be seen as an ecosystem service provider, which can be true. However, when we have the concentrations and over concentrations of cattle production and cattle rearing, such as the one that we have in Europe, as you can see here on the map, then those ecosystem services just aren't needed anymore, and we can't talk about them seriously. You can see here that in some places the number of cattle is far, far greater than the number of inhabitants of a certain region. And this is actually very illustrative of many other, um, more than anything, animal species, which of course leads to very unrational use of our resources. We're wasting them, and then this is why we need to ask ourselves, can we somehow try to circle the nutrients that we produce? Can we use our resources more rationally in that way? And this is where insects can play an important role. So if we want to make our nutrients and maybe in particular our deficient nutrients a bit more circular within our food system, then insects can help us to do that. And as you can see here, insects can play an important role in nitrogen recovery technologies. On one hand, they themselves, the insects, the larvae typically can be used in feed preparation and production, but on the other hand, the frass goes to agriculture and thus really helps in recovering the resources that we have. Here, just like in the following slides, you can see the QR code. So please feel free to scan the QR code and access the full study, as I will be going through several studies and I'll just skim the surface. However, if you want to find out a bit more, feel free to take a deep dive and scan the QR code. Of course, insects come with certain impacts as well. And here we can see the impacts that are to be taken into account. Those can also be rather important. You can follow here in each of the production phases what happens and what kind of emissions and what kind of impacts we can have there. You can also see that in pretty much every production phase, there is greenhouse gas emissions and there is some kind of wastewater that is being emitted. So we must also take into account the fact that insects are not a magic wand, and we need to be careful about how we use them, how we use them cleverly so that they can contribute and not make yet another problem, and how we can take advantage of the ecosystem services that insects can provide us. One of the projects that we're trying to, within which we're trying to learn and to see how we can use insects to limit the impacts of the whole system is Advogromed, which is focused on Mediterranean countries. So we have 7 partners from 6 countries. And here specifically, we're using insects precisely to close the loop, to make the nutrient flow circular or as circular as possible. So as said, we're using insects, both the black soldier fly and the mealworms, to on one hand provide the better feed for the poultry, and on the other hand to use the frass to replace one part of the fertilizer used in the agriculture. This is meant to help the local producers really increase their local and resilient, therefore, production. And the project is coming to an end next year. We already have some pretty good results, I would say. Second project, much bigger, is Cypromed, dealing with similar problems involving 17 partners from 10 different countries. And here we tried to, again, within the Mediterranean region, convert the residues that are obtained during protein extractions into some other proteins. And insects are, of course, an important part of this project, even though not the only one. Going further, we also worked on a book that is again trying to use insects as one of the ways we can make the nutrient flow circular and not waste any of the nutrients that we can bring back, even from something that is as seemingly as debatable as waste to food. Here we outlined some of the methods that can be used, but also technological and legal aspects that remain always tricky, as well as, of course, environmental impacts. And this is perhaps some of the new works that we have within our group, and also something where insects can play an important role. So this is the methods of sustainability assessment framework, which focuses on circularity. The research is mostly done by my colleague Beatriz Silva, and here we can see that she defined 4 different levels of circularity within the food system. And insects here can play a role by hopefully helping us move from one of the lower, 3rd, 4th level up, and therefore make the nutrient circulation happen earlier and prevent any of the loss or any of the value loss that would otherwise take place. And then once we produce the insects, what do we do with them? What's the best way to use them, and what is the most practical way to use them? There is already a variety of technologies to process the insects and to process them sustainably. Here are some of the examples. Some of the examples we've already heard about a little bit earlier. And this is what we have done within our project. So this is modular and automated unit that can process insects. So we go basically all the way to sustainable ingredients that can be used for food production. And then if we compare few different sources or a few different ways of recirculating nutrients, we can see here that if we look at greenhouse gas emissions, insects at the bottom of the table are basically the best option that we have, or one of the best options that we have. There is other options. Yeah, we can start from composting food waste, but as you may have seen in one of the previous slides, that's not really the very high level of circulation, right? So if we compare the biotransformation technologies, insects have very high circularity potential, also pretty high technology readiness. We've seen already the technologies for their production, also for their processing. Legal readiness in Europe, getting there slowly but surely. In other parts of the world, possibly there since forever, because there are places where insects are traditionally eaten. And of course, there is impact, which is again not the highest when it comes to the insects. And when you compare them with other transformational technologies, well, insects do seem to be one of the better shots that we have. So it would be clever to learn how to use them wisely. I would like to wrap up with our common future, which is a document presented by the United Nations 37 years ago now. And already there, they are setting up the system approach, and the methods are being defined, which are estimating the efficiency of nutritional circularity and the technologies that can improve the efficiency and costs, and even the legal legalization of different activities and the legal aspects. And all of these refer or can refer today to our insect production as well. So we just need to be aware that insects play an important role for something that United Nations have defined already almost 4 decades ago. And we need to use the opportunity that we have. Of course, more studies to define the synergies and interconnections are necessary, but we already have some knowledge and something to say, yes, insects can and should be used far more than they are now. If you have seen this slide already, that's because we want to make sure that you do not miss our Insect Plus Congress, which is taking place next year in May. So please book your calendars. Thank you for your attention. I will be happy to take any questions you may have, but also alternatively, here is the email of Sergei Smetana if you'd rather send your questions to him directly.
Perfect. Thank you, Dusan. I will have a look in the chat and I'll find one question related to sea algae and the example of being used for gasoline production on a commercial scale. And the question is now if also other chemical substances can be produced and can replace the fossil-based ones based on insect or alternative raw materials. So again, we have been discussing food and feed, and now we are moving also towards third dimension, we could say, to chemical substances. What is your opinion on this?
Well, as Giacomo said just some minutes ago, there is no question that we need to look at a bigger picture and maybe look at different uses of biomass for sure. But yes, I was mostly discussing and thinking of food and feed uses here within the presentation. So I would probably stick to that, as that's really the field of my research. So that's what I would know better.
Yeah. Thank you. Well, with this, I don't see any further questions. But again, as mentioned, you have all the contacts. Of course, feel free to contact the section food in case there are any questions upcoming. Also, you have the names of at least the initial presenters, and now here also the co-presenters available. So I think all of them will be happy to answer questions and provide some additional material. There are some publications out there, of course. So if there are any requests, feel free to get in contact with us. And it was mentioned several times, the next big event, which will also bring many answers to open questions and may also open some new questions, I guess. But definitively a good opportunity for networking. So, Dusan, thank you. And yeah, with this, I would like to invite all the speakers again on the floor. I think we had the opportunity to discuss after each presentation. So, as mentioned, most of the questions have been answered, and it's time for some concluding remarks, which I would like to start before handing over to Kemal again. Just very important, and I think this is a key aspect when it comes to new raw materials, that we need to consider the different facets. We have learned interesting aspects related to composition and the creation of insect as a raw material. We have seen that new processing solutions need to be developed, and this is of course also where food processing and food engineering comes into play. We have seen that the range of applications is quite wide, and also that it's necessary to quantify benefits, to really turn potential benefits into practical examples, into success stories, to show what might be researched in small scale. And a second aspect, of course, legal constraints, and we have heard this in several presentations, that here opportunities it might be much bigger as compared to what is possible currently in the legal framework. Definitively a very important aspect, food safety, but still I think also the consideration of broadening up the opportunities also with regard to legal aspects are there and will probably develop in the future. So I think a very interesting topic with many developments to come. So definitely it might be interesting to have another webinar on this topic in 1 or 2 years' time and to see how much the picture has changed till then. Yeah, with this, I would like to hand over to Kemal, and me personally would like to thank all our speakers again, and of course the whole audience for your interest and attention. Thank you.
Yeah, from my side also, I want to extend a great thank you to all our speakers. It was really great contributions. And of course, also to our audience, who really raised some important questions. And as Henry mentioned, I think it really makes sense to organize another webinar in a few years, and maybe with a more broader perspective. We brought some questions about safety, we brought some questions about allergenicity, so really going a little bit outside of the processing and food boundaries, and going maybe a little bit in the diverse direction. But yeah, till then we have to do our homework and a little bit more of a research and a more activities in trying to answer these questions and optimize in the breeding, in the processing side as well. From the webinar, it's clear that the insects have the potential to contribute to a new system, or as Giacomo says, to allow them a completely new system, and hopefully some ideas and knowledge picked up today will be exploited in a kind of joint activities with the audience and with the rest of the group. I wouldn't keep it for too long. I'm pretty sure that most of you have another appointment at 4 o'clock, and therefore I would like to thank you again for joining us, and looking forward to seeing you at some other place, at some other webinar or conference or whatsoever. Thank you very much, and have a nice afternoon, day, wherever you are.
Okay.